talk about variables, and basically there are two types that we're going to worry about. The first that we'll really be dealing with, categorical, and they're just like they sound. They're about categories, so male, female, large, medium, small, that kind of thing. And then the other type will be numerical. And numerical are numbers. Now they could be each of these. We have actually strictly categorical. Under the categorical, we will say nominal. That's kind of strictly categorical. Nominal in name only. That would be anything that really has no real order. So if you think of, suppose our variable was color, and so the different categories might be red, green, blue. Add your favorite colors to that, maybe puce or something. But we have our different colors. Now, usually you would not say that red is greater than blue or blue is greater than red or anything like that. So in those cases, the idea of nominal in name only, we're really saying that these categories have no particular order to them. Now, so what would be different than that would be ordinal. So ordinal categorical variables actually do have an order, and so you might talk about large, medium, small, where small is less than medium, which is less than large. But the thing is here they're still categorical in that it's arbitrary what we call small, it's arbitrary what we call medium, and what we call large. Now there would, we would know that a large is bigger than a small, but how much bigger? Is it twice as big, 1.5 times as big, 10 times as big? There's an order to them, but no actual specific difference there. Whereas with numerical, when we start talking about those, actually we'll have kind of two types of numerical. We have discrete, and so discrete would be things like 1, 2, 3, so integers, that sort of thing. Discrete usually would mean either a finite number, so like 1, 2, 3, that's finite, or technically speaking, a countably infinite number. That would still be something like 1, 2, 3, but it would go on forever. So 1, 2, 3, 4, 5, 6, up to infinite, up through infinity, and that concept. Then, besides discrete, we could have continuous, and so continuous would be intervals. So for instance, the interval from 0 to 10, something like that, which would include numbers like 0.5, 5.128, and so forth. Pi is in there. So these are continuous things that would have intervals, and we're going to start with the categorical variables. We're going to look at things like counting. So we'll look at again going back to like the cancer and smoking sort of thing, what you tend to do with categorical things is so for instance smoking, yes or no, and then here we would have cancer, and then that would be a yes or a no. And what you might do is in an experiment or an observational study, you would look up all sorts of numbers. So smoking yes, cancer yes, maybe in your study there were 50 of those. Smoking no, cancer yes, maybe there were 5 of those. And smoking yes, cancer no, maybe there were like 5 of those. And then smoking no, cancer no, maybe there were 40 of those in your study. And so this would be something you would tend to do with strictly categorical variables. And looking ahead, the type of thing we're going to do here is look at, well, do we think, can we see that it matters which column or row we're in? So in other words, if you tell me a person has lung cancer, and so we'll add lung up here, lung cancer, then I'm going to predict differently as to whether they were a smoker or not. Right? If you tell me they have lung cancer, I can see from this data that I would probably predict they were a smoker. But if you tell me they did not have lung cancer, I would predict they were a non-smoker. So I'd be over here because that would be the most common thing of these two. And so you see, this is the idea of dependence, is that by knowing something about the cancer, I will predict about their smoking habits, or vice versa. If you tell me they're a smoker, I'm going to predict they're going to end up with lung cancer. If you tell me they're a non-smoker, I'm going to predict they won't have lung cancer. And so you see, knowing something about their smoking habits then changes my prediction on whether or not they would have lung cancer. So that's a very typical thing we would see from 2 categorical variables. Now 2 numerical variables. So I'll move over here to where we had the numerical. 2 numerical variables, we tend to think of x and y. And the way we would see this same sort of thing here, now it's kind of hard to go with the smoking and cancer idea here, because really those are a count. But if you could do something like, instead, this would be something like amount of tar in the lungs, and then this side being something like the probability or likelihood of getting cancer. So kind of dealing with the same sort of things. Or instead of tar, I could go with total number of cigarettes smoked or something like that. So those would be numerical variables. Now, what I would probably expect, is in this case, is as more tar or more cigarettes or something like that, that probability of somebody getting cancer would go up, and I might see a picture like this where, very little smoking or very little tar, very low probability of getting cancer, but the more tar in your lungs over time, or the more cigarettes you've smoked over time or something like that, the higher probability of lung cancer. And so what we see here is actually, now it's a sort of the opposite reflection of what I see here. Now I could change my categories to make it look the same. But you see, with the numerical variables, if I were to sort of section this off into 4 parts and count the number of dots I see in here, notice that what I would have is, again, maybe I would have, 20 dots there, just 2 dots here, 3 dots there, and maybe 30 dots here or something like that. But you see that count, if I sectioned it off, I'm really putting it in the categories, and I end up being able to see the same thing here as here. And so when we have 2 numerical variables, we're really looking for that unbalance again. In other words, do I see some sort of upward trend or downward trend here? We sort of see this downward trend, right? All the dots would be here and here, so we'd see sort of a downward trend. And that's how they're related. So you could, instead of saying, a strict probability or likelihood, like, oh, they've got an 80% chance or a 70% chance, we could go with high or low and move those to categories. So you see they're very related. When I count here in these cells, it's really not that different than, say, counting dots in here. And so that's kind of what we're dealing with when we deal with these different types of variables. Okay, so we'll call that good for this one, Introduction to Variables, and move on to other things.